Hello guys. So today we will talk about Docker and Kubernetes. So we'll talk about these two topics. So let's take this scenario. A normal day in a life of a developer. What he does is he's a developer, so he writes a program. So suppose he has written a Java program. So he's written this code. Then what he does, he builds it, resolves any issues, any error, and then he gets a jar file. Okay, jar. And then he runs this jar to run his application. So in this way, this application is running. Now next time, suppose if I want to run this jar, so he will give this jar to me. I will have my own desktop or a machine where Java is installed. My path is set. Java path is set. And then I can run this application through this jar. Okay. But what if in my system I don't have jar? Sorry, I don't have Java. So in that case, I have to build that system and run this Java code and do. So this was the fundamental issue with the setup of dev and ops team. So dev team used to develop and give the artifact to the ops team. Okay. Then ops team had their own platform to run these codes. So they used to complain, okay, this code is not working, this is not working, that is not working. But the actual problem was not in the code, but in the platform or the infra where they were running the code. Here they might be missing some packages. They might be having some missing dependencies. So this used to create a lot of conflict between dev and ops team because both of them were working in silos. So to overcome this problem, this Docker came into picture. So with Docker, we can Docker is a container runtime. So you can run containers using Docker. So if you want, so today we will discuss about Docker file, how to containerize an application. So this is an application, this part. Now, if you want to, this is an application. Now, if you want to containerize it to run it on cloud, we need to use Docker. So what we can think this as of a CD, like a game CD or a movie CD. When we buy a CD, we have the exe. Suppose this is a FIFA game CD. We have an exe. We have some softwares which is needed to run this FIFA application. Then we have our own machine where we have OS installed. Okay, so suppose this is packages and dependencies, and there's a system with OS installed on it, and then we have a CD. So complete this things are needed to run my game. So now we will containerize this my jar. So what we need to have, we need to have a Docker file. So this is a text file. Docker file is a text file wherein we run the commands, we write the commands which includes the base OS, the application source code, we have all the dependencies if any, and then we have a cmd or an entry point command. This will trigger my source code, like the very first command which is needed to run my application. Okay, and when we build this this Docker file, we get a Docker image. So Docker image is a blueprint of my application. With this Docker image, I can have multiple instances of my application running. So suppose now if you have 100 machines, okay, so you need not worry about what the underlying OS is there, what all packages and dependencies are there. So if we have a Docker or Podman installed, Docker and Podman are the two softwares needed to run our Docker images, to run to run our Docker images and to run any container. So if Docker and Podman is installed in your machine, you can ship your Docker image, which consists of your application, all the packages and dependencies, and then you can run on your machines. So this was about Docker image. I will talk about this, how to write a Docker file, how it will be converted to Docker image, what happens when we run a Docker image. But for time for in this session, we'll just focus on the overall architecture or how things work. So another one basic example, if you want to relate what is happening with Docker file, your application containerization. So think of this scenario. Suppose you went to office and you have your own system. In this system, you have internet connectivity. Okay, then you have your hard disk and all, wherein you have files. So you have got a task to create a PPT about your organization. So they have given some documents related to your company. Okay, company document they have given. Now this is your Windows machine or a Linux machine. So you have a OS machine with OS. Then you have a PowerPoint presentation software. Then you have a browser, and then you have a paint software. Okay, then you use all these things to create a PPT. Suppose this thing I have to give it to, so these are the basic things. Once I have provided you all this, then your work comes, then you will solve. Okay, you will find this, you will go through this document, you will edit some images in this paint software, and then you will create a PPT. Huh? Ask 100 students to make this PPT. Um, my work will be in this 100 machines or 10 machines. Suppose 10 students are there. In 10 machines, I have to install this OS. I have to make sure that my PPT software runs with this OS. My pen software should run, browser should be there, this document should be copied in all the 10 machines. So what I will do is I will write a Docker file. I will mention the OS name here. Suppose it's a Ubuntu. I will copy the company document. This I will prepare in my own machine where I have this company documents. So I will copy company doc. I will move this packages. Suppose I have to move a paint software in this. I will give a paint software, PPT software. Okay, I will copy. I will create a directory. This is the working directory of PPT directory I will create. Okay, and some command I can write, or one, or just like this I will write a Docker file. I will name it as a PPT image. Okay, so now this image is ready. So my in this image, this CD, think this as of a think this of as a CD. So in this CD, my company documents are there, my OS is there, which is required to run this PPT software, browser software, and this paint software. All everything dependencies in this image. Now I need not worry about running of installing the browser, the software, paint software, and everything in 100 machines. I will just ensure all my machines have this Docker installed or Podman installed, and I will keep my this Docker image, the image PPT image in all these machines, and I will run this Docker run command. So when I run this Docker command, a screen like a container will run, and in this container, all my these 5 things which are my prereq to create a PPT will come. So now that the fundamental problem or the problem of dev and ops fighting over the platform or environment is resolved. So this Docker image, from Docker image we get containers. Okay, and when we get containers, they are supporting workloads which is needed to run the container. So we call it as a Kubernetes workloads. So Kubernetes is a container runtime is an orchestration tool to manage the containers. Docker is a container runtime, and Kubernetes is to manage those containers. Okay, so if you think it is as a there is a Docker underlying technology. On Docker, on top of Docker, we have Kubernetes, and on top of Kubernetes, we can have multiple products we have, like we have OpenShift container platform, we have Google GCP, we have AKS, like IBM's Kubernetes service IKS we have. So those things are there. So we have pods as a Kubernetes workloads. We have pods, we have deployments, we have PV, we have PVCs, we have secrets, we have config maps. So this is part of application code. This is part of storage. This is again application part. So these things are there. Hope things were clear to you guys. In next session, we'll talk about the actual Docker file, actual commands, and we will containerize one Java application.